What was important about Darwinism was that it not only was a theory of how life changed, but it was a theory of how life changed in a completely undirected and unguided way. So one of our American textbooks that is completely not biased in any way says this, it puts it this way, it says, by coupling the undirected, purposeless variations to the blind, uncaring process of natural selection, Darwin made theological or spiritual explanations of life superfluous, unnecessary. And so with Darwinism, we get this rise of what sometimes was called scientific materialism or atheism, and with the idea that there's no guiding hand behind evolution. It's not theistic evolution. It's not teleological. There's no purpose behind it. It's a completely undirected, unguided process. And that, as Richard Dawkins would later say, made it possible to be an intellectually fulfilled atheist. We can now explain the appearance of design in living organisms as a result of an unguided, undirected process, and therefore there was no need to invoke a designing intelligence or a creator of any kind. He was later, Dawkins has been quoted most famously in his book, The Blind Watchmaker, saying that biology is the study of complicated things that give the appearance of having been designed for a purpose, where the key word is appearance, the illusion. Why is it an illusion? Because there's this unguided, undirected process called natural selection that can produce the appearance of design without being guided or directed in any way. It can mimic, it's often said, the powers of a designing intelligence, but it's not intelligent. There's no intelligence allowed. And so this perspective has given rise to a lot of intellectually fulfilled atheists. And many of them are kind of very popular, and they've had a very strong voice in the culture. Lawrence Krauss. Unfortunately, even Stephen Hawking got into this act late in his life. Bill Nye, the science guy, even though he's not a scientist. And then the really great physicist, Steven Weinberg, have all been exponents of this idea of scientific materialism or scientific atheism. And Richard Dawkins had a lovely way of framing this, even if he got, in my view, the issue wrong. He says, the universe we observe has precisely the properties we should expect if at bottom there is no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. Blind, pitiless indifference for him is kind of shorthand for an unguided, undirected process, materialism. Matter and energy are eternal and self-existent and self-organizing, and they can generate all the intricate designs we see in the universe without there being a guiding hand behind it. This is the Darwinian and scientific materialist perspective. Now, it turns out that there are at least 3 major discoveries that are not what you would expect if the universe were the product of blind, pitiless indifference. Dawkins says that the universe has exactly the properties we should expect if it was only materialistic processes at work, but there have been 3 major discoveries, and I've written about them in my book, Return of the God Hypothesis. What I'm going to do today, and which is kind of fun, is to highlight the Cambridge angle on each of these discoveries, because it's non-trivial in each case. If you read some of my work, or if you've heard one of my talks, I won't belabor all the things I usually talk about, but you probably remember I've talked about Edwin Hubble, with the astronomer, the lawyer who went into astronomy in the 1920s. He began to use these, at the same time as he went into astronomy, they were building these great dome telescopes. And as a result of the one in Southern California at Mount Wilson, he was able, for the first time, to verify that the nebular smudges that the nebular structures in the atmosphere were actually galaxies beyond our Milky Way. And further, he was able to show that those galaxies are racing away from our Milky Way galaxy, and they're doing it in every quadrant of the night sky. And so he was able to show that the further out you look, the faster those galaxies are moving away. And the best explanation of this idea of an expansion, where the things further out are moving faster out and the things closer in are moving a little less fast, was a kind of spherical expansion, like a balloon being blown up. How many people have seen me illustrate this with just puffing on the balloon? Is this, okay. So if you just think of I've got one, but I don't want to belabor illustrations that people have seen 100 times, but if you just think of a balloon blowing up and you think of, I usually draw galaxies on the surface, and as the universe is going in the forward direction of time, the universe is getting bigger and bigger and bigger. The volume of the universe is getting bigger. It's like It's like a balloon expanding. And what Hubble realized is that his observations meant that we had an expanding universe. But if you wind the clock backwards in time, that expanding balloon would have been smaller and smaller and smaller at each successive point in the past, till eventually all that matter would have had to have been in the reverse direction of time. It would have congealed to a starting point, marking the beginning of the expansion of the universe, but also arguably the beginning of the universe itself. Now, this was a discovery that was made mainly in the United States by Hubble, another colleague of his, Humason, an earlier US astronomer named Vestos Leifer. But there was another angle on this that was really interesting. And it was a consequence of the work of a German scientist with very bad hair, with a very thick accent, who typically did not match his socks, and was therefore a hero of mine. This is Albert Einstein. And John is going to give a little test on this equation afterwards, so don't worry, you don't have to take it down now. But he had this new theory of gravity, and it was slightly different than Newton's, and it was the idea that gravitational force is caused as massive bodies curve the fabric of space-time. Now, this is no less mysterious than Newton's theory, because how does matter curve space? And then the other part of the theory was the curvature of space causes the other matter to move and take curved trajectories. But since space is empty, it's no less mysterious than Newton's theory, but it kind of worked. The math was better. But it also had an implication. You could think of it as like putting a bowling ball in a trampoline, how it will create a divot, right? It curves, it creates a contour in the trampoline. Well, that was the idea, that the massive bodies would create a kind of contour in space. And but if that was true, Einstein realized that if his idea about gravity was true and it was the only force operating in the universe, then eventually all the balls would come to the center, okay? And all the matter would congeal. And there would be no empty space in the universe. We'd just be in one giant black hole. But we don't live in that kind of universe. We live in a universe where there's empty space. And so he thought there must be some other kind of force at work that's doing some pushings, an outward pushing force that counteracts the theory of gravity. And he called that idea the cosmological constant. And then he made one other move that was completely arbitrary. He assigned a precise value to that outward pushing force that was equal and opposite to the inward pulling force. So he could depict the universe as being completely static, not expanding outward from a beginning and not collapsing backwards either. And the reason that he chose that value was that he found the idea of a beginning to the universe rather distasteful. It kind of triggered him. He thought, if there's a beginning, then what comes before that? That sounded like the Genesis account. And at this point in his career, he was a pretty staunch scientific materialist. And so he sort of inserted this fudge factor into his equations, and it preserved for the time being the idea of a static universe, not one expanding outward from a beginning. Well, meanwhile, there was a young Belgian priest who started to work with Einstein's equations, and he was working here in 1923 at St. Edmund's College. He was Belgian. He did most of his scientific career across the Channel, but he had a really crucial year here where he was working on what are called the field equations, Einstein's field equations. And he showed that Einstein's idea of precisely balancing the outward push to the inward pull didn't ensure that the universe would be static, because even the slight alteration, perturbation in the distribution of matter and energy in the universe would throw that balance off and cause everything to go into a black hole or into a heat death. And so at a physics conference in 1927, Lemaitre meets Einstein, and they're in a taxi cab together going to the conference, and he confronts him with this. And Einstein, of course, doesn't like it too well and tells Lemaitre, he says, well, your mathematics is admirable, but your physical intuition is abominable. And the scientists are always so measured in the way they speak, And so there was this, Einstein basically, I don't like it. Your math is right. This idea of precisely balancing things is unstable, but I just don't like where this leads as far as a physics theory of the origin of the universe. We're back to a beginning, and that sounds like the Genesis text. Well, there are other scientists who didn't like this idea as well, the idea that the universe had a beginning, and one was Sir Arthur Eddington, who was also here in Cambridge. And he was famously quoted as saying, philosophically, the notion of a beginning of the present order is repugnant to me. I should like to find a genuine loophole. I simply do not believe the present order of things started off with a bang. The expanding universe, outward from a beginning, the expanding universe is preposterous. It leaves me cold. Well, this alternate theory in psychology is known as denial. And you see, can you see what the evidence is that he's citing? Why he doesn't like it? He says, philosophically, I don't like it. It's challenging his worldview. It's challenging scientific materialism. Now, to his credit, Eddington has a meeting with Einstein here. And he doesn't like the idea, but he tells Einstein, hey, look, we got to get with the program, and you got to get with the program, because out in California, at the Mount Wilson Observatory, they're seeing the evidence of this expansion. And so Eddington, despite his own personal reservations and distaste for what later became known as the Big Bang Theory, tells Einstein he needs to go meet Hubble. And so Einstein does subsequently go out to Pasadena, to the Mount Wilson Observatory, 1931, fascinating newsreel footage we have of this encounter, moving pictures. And Einstein goes into the telescope, he takes a peek, and then 2 weeks later, this is Hubble in the background with a pipe, and 2 weeks later, he does an interview with the New York Times and admits that the universe is not static, and then he says the three hardest words to say in the English language, I was wrong. Okay. And he later, to his credit, he said that his fine-tuning of the cosmological constant to obscure the evidence for the beginning of the universe was the greatest blunder. In my book, I said it was the greatest blunder of his career. I misquoted him. It was stronger. He said it was the greatest blunder of my life. Okay, he let his philosophical predilections distort his evaluation of the evidence. Now, this whole issue of the beginning resurfaced again, and it did so here in Cambridge. In the 1960s, Stephen Hawking, while doing a PhD, began to think about Einstein's theory. He was doing black hole physics. And he began to think more about this idea of general relativity and how massive bodies curve space. And he was thinking, well, in the forward direction, and by this time he was also aware of what the observational astronomers were discovering about the universe expanding outward in the forward direction of time. And he realized if that was true, then the mass of the universe would be getting more and more and more diffuse. And if the mass of the universe is more diffuse, then since concentrated matter curves space, then the curvature of the universe should be getting less and less pronounced. But by the same token, he realized if you back extrapolate and go in the reverse direction of time, the matter would be getting more and more and more densely concentrated as you go further and further and further back in time. But if the matter is getting more densely concentrated, then the space would be getting more tightly curved, and then more tightly curved, and then more tightly curved, and finally you would reach a limiting case where you couldn't go back any further because the curvature, the matter would go to an infinite density and the curvature would become infinitely tight. Well, an infinitely tight curvature corresponds to zero spatial volume. And question, how much stuff can you put in no space? No thing fits in no space, okay? And so this is a profoundly anti-materialistic consequence of modern physics. In fact, the picture of the universe that's painted by this idea, Hawking eventually proves this, and is part of his 1966 PhD dissertation. But a consequence is that the universe is then portrayed in terms that are very similar to what the medieval theologians described as creatio ex nihilo, creation out of nothing physical, because there's no space to put anything. And if you've seen the little film, A Theory of Everything, about Hawking's life, they depict his PhD dissertation. And he's standing at a wooden table across from Roger Penrose and Dennis Sciama and these very prominent, established Cambridge and Oxford physicists. And they're picking this poor thesis apart in chapter 1, and he's got an error in a derivation. In chapter 2, he's got spelling errors. In chapter 4, he's got... But then they say, but Stephen, this third chapter, this is a black hole at the beginning of time, a space-time singularity. This is genius. And then they shove the book across the table and say, congratulations, Dr. Hawking. And they use the title, he's passed. It's a really dramatic thing. In any case, this kind of really focuses people's attention on the consequences of this idea of the Big Bang. That is, we're not talking about a primeval atom that's been sitting around forever waiting to explode. We're talking about the origin of matter, space, time, and energy itself. And in 1985, I attended a conference in Dallas that completely changed my life. It was a conference of atheists and theistic scientists debating the origin of the universe and the origin of life. And in the first session, one of Edwin Hubble's former PhD students, by this time a very prominent astrophysicist himself, Alan Sandage, a well-known Jewish agnostic who was pretty much a scientific materialism, ascended to the podium and sat on the wrong side. He sat down with the theists instead of his fellow materialists. And in his talk, he then explained how the evidence from his own field that he had helped verify, he had helped Hubble verify that the universe was expanding in every quadrant of the night sky. And he announced that he had become not just only a theist, but a Christian. And he had done so not in spite of the scientific evidence, but because of it. And in describing the evidence for this singularity at the beginning, he said, here is evidence, he said, for what can only be described as a supernatural event. There is no way this could have been predicted within the realm of physics as we know it. I have the footage of this, and I watched it later many times. He didn't seem too pleased to be saying this. It was a kind of gravity about him that he'd come reluctantly to this position. But I was 27 years old and kind of blown away. And there was a similar talk about the origin of life, and between these two things, this ended up sparking in me a desire to study this more deeply, and it's the very thing that led me to this place a year later. And it's not hard to see why this is so troubling to a scientific materialist, because after all, the first words of the book of Genesis are, in the beginning, in the beginning. So, whereas Dawkins has said the universe has precisely the properties we should expect. If there's no design, no purpose, nothing but blind, pitiless indifference, in cosmology, it didn't turn out that way, hasn't turned out that way. The universe we see is not what we'd expect if we had an eternal self-existent, if matter and energy were eternal, self-existent, self-creating. There was a beginning. They weren't around forever. And this whole idea of a beginning suggests the need for an external cause beyond the material universe. When I was on the Piers Morgan interview, the way I explained it, tried to get it across to a popular audience, was to say, before the origin of matter, there was no matter to do the causing. There had to be something outside of the material universe.